There we are. Cool. All right. How is it going, everybody? So it's been a little while since I've done a live stream, and I'm just, chilling here at home, doing some labs, and so I decided to go ahead and uh, basically just do some labs. I was actually um, I went to Cisco Live and came back, and I had a lab built and stuff like that, and then I found out the lab crashed. So instead of trying to figure out and reboot and play around with that game, I figured just rebuild the lab, build a little bit more in depth. So what we're going to be doing over the next, I don't know, maybe hour or so, is going through and configuring a bunch of service spreader stuff. And the reason why I'm doing a lot of service spreader stuff is because the new exams drop at the February 24th. So I figured I've got exactly 8 months until the version 4 of the service provider exam is no longer valid. So until the new version 5 kicks off on February 24th. So what I'm going to be doing, as the stream title says, I've already done OSPF and LDP. I've already got those up and running in the core. So what I'll do is what I'll go ahead and set up is the BGP configuration, and then the VRFs, get the layer 3 VPN up and running, and then do some layer 2 VPN and some MPLS traffic engineering for the layer 3 VPN stuff. So it's going to be a little bit of inter-area traffic engineering. So if you've ever seen anybody do regular traffic engineering within a flat area 0, it's pretty simple. You just basically tell the TE tunnel at the remote end, and then everything pretty much works. Where in the inter area it's a little bit more involved, and I learned a little bit about this when I was at Cisco Live. I actually never played with it before, so that's what we're going to be doing. So if you, I am watching the channel, and I'm watching the chat. So if you guys have any questions or anything like that, feel free to drop them in, and we can definitely go and I'll answer them as they come in. Hopefully they come in. I get them pretty quickly. And I don't know what the lag is on the stream itself, but hopefully it's not too bad. But we'll play with it as we go. So let me go ahead and bring over the over Super Putty, which is what I'm using for all the configuration stuff. So one side note that I was playing with when I was in Cisco Live is I sat through a couple sessions that required things like segment routing and stuff like that. And what's up, P. Emmanuel Saki? How's it going? When I was going through some of these sessions, a lot of the command outputs that I was getting were I couldn't deploy segment routing within the traditional sense. So normally, if you're going to create an MPLS traffic engineering tunnel and you go interface tunnel whatever on iOS, what'll end up happening is you can tell the TE tunnel to use segment routing instead of using RSVP as a signaling method. The drawback to that is that's not the way that segment routing is really supposed to be leveraged, especially in iOS. So in iOS XR, where it's way more involved, and to me it seems like they put a lot more effort into the XR platform. So what they end up doing is they have this dedicated segment routing sub-configuration mode where you'd actually configure your traffic engineering policies underneath SR. And that's what this XRV9K box is here. Although I was playing with that last night, and guess what? It crashed on me. So one of these days, I'll blow away the router. I'll bring it back up brand new. But XRV9K does work. And I also tested out layer 2 VPN with it. And just a straight up X-Connect, which is basically just a point-to-point layer 2 VPN between CSR1 and XRV9K1 here, between IOSP 18 and IOSP 12. And boom, it worked. I had an EIGRP adjacency. Layer 2 VPN was supported in the data plane, not just the control plane. So I was really happy about that. So with that being said, what we're going to go ahead and do is kick off the config. So the config is, like I mentioned just a moment ago, OSPF and LDP are already running. So we'll go ahead and verify that real quick. So we're going to go ahead and let me move the mic over a little bit so I don't have to strain myself to be able to see where I'm typing. If we do a show IP route, we're going to see we have a bunch of inter-area routes, which is a good sign for me because I'm testing out inter-area connectivity. And if we do a show MPLS forwarding table, we can see that there's a bunch of MPLS labels. Now, I haven't done anything specific in terms of, you know, the MPLS, like having specific label ranges per router to make it easy to figure out. Actually, I don't like doing that. I actually like to jump through and actually have to do a hop-by-hop packet walk and stuff like that. So there's a question from in here. It says, can I go along with you using Cisco Packet Tracer? No, unfortunately, Packet Tracer won't support this. You can use GNS3 with the 7200 series platform as well as the 3725s on pretty new code. Anything 12.4 should be fine. 15 code would be fine, but Packet Tracer doesn't support this. So unfortunately, it's one of the things that I don't like. It's one of the reasons why I don't like Packet Tracer, but you know, it is what it is. So now that we have verified the iOS and the provider edge side, which is what we really need to focus on, let me go ahead and do a couple of trace routes to the remote side. So an example of that would be, let me squish this down a little bit, and I'm going to go ahead and bring this up just so we can have CSR1 and XRV10 inside of the visibility of the topology. And I'm going to do a trace route to XRV10's loopback. I'm going to source it from my local loopback, but I'm going to go numerically, which means I just don't do a DNS lookup. So I'm going to go trace, and you can see that there's a labeled path to the all the way there, except for the last hop. The last hop, which is in this case here, is XRV9 and XRV8. And the reason why you see no label values here is because of the PHP process. So the penultimate hop popping process. You can disable that with explicit null on the PE routers if you need for specific quality of service deployments, but for the most part here, this is where we're going to sit. So what I'm going to go do now is the next chunk of time that we're going to spend here is going to be pretty much used for going into the BGP configuration, the VRF config. I'll be doing it both iOS and XR. I'll be doing it for VPNv4, but you can do it for VPNv6 as well if you'd like to do so, and stuff like that. So as we go along here, if you have any questions, feel free to ask. If you would like to see something specifically demoed, and I have the ability and knowledge to do so, I will do that. So Nick asks, will this be saved to YouTube video on demand? Yes. What'll end up happening is however long the stream is, after it's done being streamed, it'll get rendered and it'll become a live video. So if you check back, I don't know how long ago it was a couple of months ago, I think, where I did another live stream, and it took about an hour for the rendering, and then it was a live video. So it was like Rob Riker live stream. I came up with a crap title for the stream, but you know, it did work. It's there. It's about an hour long or so. I cover a lot of the same things, but this is, and the main reason why I'm back in the SP track is because, well, the new exam drops, and I've been so far along the track, it just makes sense to finish it out. So a lot of the config that we're going to be doing on the iOS boxes and iOS XE, a lot of that configuration is going to be kind of copy and paste. So I'll be able to copy and paste it on, to configure it on one router, copy and paste it into the other ones. XR is the same concept. So we'll do that for a lot of that type of stuff. Anything that's platform specific, iOS or iOS XR, I'll go ahead and break down where some minor subcomponents like the route target values, the route distinguishers, things like that, and then how the VPNv4 process comes into play. And then we'll do a little bit, yeah, no problem, Nick. We'll go ahead and get BGP peerings up and stuff like that. So what's going to end up happening is, if you were to look at the two connections that come down from each PE router, you might be wondering, well, why do you have two connections? Well, the main reason I have two connections is because I want to be able to test both layer 3 VPN and layer 2 VPN, and you can run both concurrently on the same provider edge. So what that means is CSR1 on the lower numbered interface will always be the layer 3 VPN device or connection. So what will end up happening is this will be where the layer 3 VPN connection comes into play, and it's a dedicated interface so that I can then, if I want to carve it up to do a bunch of .1Q trunks or connections to do different VRF configs and play around with different policy options and stuff like that, that gives me that flexibility. And then with the higher number interface, gig 5 in this case, would be for layer 2 VPN. So I can do things like Xconnect, layer 2 VPN CLI, and we're gonna go through some basic layer 2 point-to-point connectivity, and then some VPLS, and then we're gonna dive into a little bit later on down the road. We'll dive into some the inter-area traffic engineering. So if you've ever dealt with MPLS traffic engineering with inside of a single area or a single IS level, it's pretty straightforward. You don't really, as long as you have reachability across end to end, it's good to go. But this is something that with inter-area, it's pretty easy to do. You just have to know the caveats to that. Another question, is that a CCNP or CCIE? I guess you could consider kind of a mix between the two. It is probably a little bit more advanced than what CCNP would do, but not quite CCIE, in my opinion. You can get really into the weeds on the CCIE stuff, but you know, I would say it's good for both if you're looking to learn how this stuff works at the end. But that's how we're going to continue with that. So now that I've explained the topology and the kind of flow of the stream, we'll go ahead and get all that squared away. If I go mute, it's not because the stream is goofy. I'm getting over a cold, so I don't want to blow your eardrums up by me coughing. So I'll mute and then disappear for a second. I'll come back. So, but yeah, other than that, that's pretty much where we're going to start off with. So, with that being said, we're kind of into the mix here a little bit. So we'll just go ahead and get started. So VRF configuration wise, we're going to be using the definition capability. So both IPv4 and IPv6. So we'll type in VRF definition, and you can name it whatever you want. The name of the VRF is 100% locally significant. It's the route target values and the route distinguisher values that could cause you problems down the road if you don't know what you're doing with them. But here I'm just going to call them test, because we're just testing at this moment. I've deployed this in production a number of times with the configuration that I'm going to be doing, so there's nothing super complicated about this. Also, another point is that I forgot to mention is we're only going to have two customer routers per customer. So the top set of routers here, 12 and 15, are going to be customer 1. 13 and 8 and 16 will be customer 2, and then 14 and 17 will be customer 3. And this will give us a lot of flexibility in terms of who we're sending traffic towards and stuff like that. And that will allow me to show you on customer 1 how to do a TE tunnel to CSR4, and then on the reverse path for customer 3, set up a TE tunnel on XRV10 towards CSR3. So things like that will be pretty straightforward for the most part, and go from there. So another question came in. Yeah, well, thanks for joining first and foremost. I can publish the configs, absolutely. The topology, I can take a screenshot of it. Here's the only drawback that I have right now, is I'm using the free version of Eve, which doesn't allow me to leave the topology and then save it as a file, if you will, and then share it out to you guys. Excuse me. So feel free to literally take a screenshot of my screen and then build whatever you have in whatever platform you decide to use. I have no problem with doing that, or wait till the stream is done and then do it then. But this gives you a lot of flexibility, so you can do whatever you want with it. But I can publish the configs for whatever I'm doing, or you can just follow along. The IP addressing is pretty simple, and you'll see that as we start moving forward. But yeah, I can do that, since you asked so nicely. So with that being said, what we're going to do now is with the route distinguisher, I'm going to be using the BGP autonomous system number of 100 in the core. So it's going to be 100:1 as the route distinguisher. And this has to be the same across all of your PE routers. However, that's not entirely 100% true. You can have it vary between PE routers. I don't recommend you do that, because then that will skew your results and your outputs from your VPMD4 outputs. But it doesn't technically matter. Now, another thing that you can do is you'll notice that I haven't jumped into an address family yet, and you can actually specify the route target values that you want to import and export on a per VRF basis, so, and per address family basis. So in this case here, I haven't defined a route target value, but if I wanted to, I could specify this, and it'll be applied for both IPv4 and IPv6 at the same time. So regardless of how I do it, well, if I do it globally or at the main VRF config mode, then it'll apply for all the address families, but for this specific VRF. So because of that, if I wanted to do any, say, VRF1 to VRF2 route leaking, what I would end up having to do is I would have to go and export a route target on one router in one VRF and import it on another, what they refer to as extranet. So if you were to go look up things like multicast VPN specifically in iOS, it's the label switch multicast config guide, and in iOS XR is the layer 3 VPN portion of the XR config guides for multicast. You'll actually see an extranet where they talk about doing that. But in this case here, we're just simply going to do the, because it's going to be a global config, we're going to keep it simple from the beginning. I'm going to type in the route target and then both for import and export. I'm going to go ahead and set it up for 100:1 is the same as the route distinguisher. It makes it easy to keep track of what's going on. So with that being done, now I have to define the address family, and for V4 and V6. I do it for both, even though I'm only going to be demoing V4. So with that being done, that's as far as I need to go on customer 1 and for CSR 1. So I can do show history and literally copy and paste. Where's my mouse? There's my mouse. Take this and jump over to CSR 4, go to global config, right click and paste, and we've got the VRF config applied. So on CSR 1, I now need to place the interface inside of the VRF. Now, what's cool about the configuration here, if we do show IP interface, if I can type, on gig 4, gig 4 is actually shut down at the moment, so we type interface gig 4. If we simply place the whole interface inside of the VRF, that's fine. But if we wanted to move, let's say, a subinterface, gig 1.10 for example, into another VRF, we could do that as well. So there's a lot of flexibility in terms of how that works. Pardon me. So what I can do now is I can type in VRF forwarding and then test, and then no shut the interface. Now, if you had an IP address applied to gig 4 and then you apply the VRF, then it's getting moved when you apply the VRF config. It's getting moved from the global routing table to the VRF table, so the VRF test, and that's its own unique routing table. That's why VRFs allow you to multiplex or virtualize the router, kind of like an ASA with contexts. So here, if I just type in IP address of whatever, then it's going to apply. But let's say, for instance, you get into maybe the new CCMP exams that are coming out in February, or the new CCIE, and the config is wrong. Maybe the interface is supposed to be in a VRF, but it's not, but it's already completely configured. If you go in there and you put the interface into a VRF without checking the interface configs first to see if there's an IP address, the IP addressing will get wiped out for V4 and for V6. So you'll have to reapply that down the road. So it's a good example to take a look at the config ahead of time. In this case here, there is no IP addressing, so it really doesn't matter. But what I'm going to go ahead and do here is type in the IP address of 10.1.12.1/24. Now, you can use private addressing, you can do public addressing. It's up to you and how you want to go about doing that. But that's basically, I choose to use private addressing and then use the router numbers in the second and third octet, because it just keeps it easy to follow the trace route. Because then you know what box you're flowing through as you're doing your traces and stuff like that. So that's why I choose to go that path. So now if we type in do show IP interface brief, the interface is configured. Now if we do a do show IP route connected, you'll see that the 10.1.12 network is not in the global routing table. If I want to look at the VRF test and connected, then it shows up here. So right now we know that it's operational inside of that VRF. And if we do show VRF, we can tell that in the VRF test, we have gig 4 is applied there. Now, if we want to create a subinterface to test something out, for example, I see a lot of people test out things like What's up, Norman? And shout out back to you from here in the Upper Midwest. I hope Bermuda is treating you well. So basically, what will end up happening now is if we decided to go and do a sub interface for a specific, I don't know, we decided we wanted to test multicast or some other type of service with another VRF, we could totally do that. And that would give us the ability of doing a sub interface and putting that in another VRF. Because technically speaking, you can by doing it, putting another VRF on another sub interface, then you have the luxury of using encapsulating it with .1Q, and it's just a trunk link. So it's just carving it up a different routing table. So you'll see what I talk in probably the next stream. I'll do some more advanced manipulations, but a lot of people think that if you place the main interface into a VRF that you can't put sub interfaces into a VRF, and that is not the case. You can totally do that. So with that being said, we're good to go there. On iOS v12, we're going to go ahead and configure this guy. So we'll go into, this is regular iOS, by the way, in case anybody was curious. This is the same stuff that you would get. The CSR1000V, VIOS, and XRV9K. If I pay the $200 a year for the viral licensing, I don't actually use viral, but I pay for the access to the operating systems. And so I just download the QCOW2 image, I rename it based off the Eve naming structure and their how-tos, and upload it to Eve's the virtual machine once it's up and running. So pretty straightforward stuff for the most part. So I'll type interface gig 0/0. I'll no-shut the interface. It does take a couple seconds for this to work. And then I'll type an IP address of 10.1.12.12/24. And both sides of the connection do not need to be in a VRF. However, you can do a VRF on the CE side, especially if you're trying to do things like VRF-aware DMVPN, VRF-aware FlexVPN, things like that. Those are options for you if you wanted to do those. But if we do ping 10.1.12.1, I should get a response from CSR1 back here momentarily. Let's see why it's not working. Did I do show IP interface brief? 10.1.gig 0/0 gig 4. Did I not? Oh, wrong router. Do show IP interface brief. Gig 4, do show run interface gig 4. 12. Oh, did I ping the wrong IP address? Haha, no, I pinged the right address. Why is that not working? Oh, there it goes. Okay, so it's just being slow. So Norman asks, which lab environment do you recommend for someone who is trying to quickly research? Good question. I would say Eve is pretty versatile. So is GNS3. For the longest time, I used just CSRs and XRV routers inside of ESXi, and then I would just map all of the specific interface to a vSwitch and go that route. Well, you can if you want. You can use viral if you like. It's probably, it takes a little bit of there's a learning curve to get it up and running, but I don't like the fact that you can't add things to it. Like, for example, when I was doing security work, Eve was easier to add a Windows box and then add internet connectivity to it, and then go and test out any connect and then all the different, firewalling features and stuff like that. I find Eve to be probably the most versatile, but there is a pretty, at least when I first started playing with it, it was a pretty steep learning curve. And that was one of those things where I had to spend a lot of time and do a lot of Googling to figure it out. Now it's a piece of cake. I know exactly what to do where and stuff like that. And I put out a couple of videos on Eve a while back, but I prefer Eve over everything else because, its support is like second to none. There's no other platform that I'm aware of that supports as many things as Eve does. Now, I'm not saying that they don't, but I know a lot of folks like GNS3. I have had good and bad luck with GNS3. That's why I don't use it very much anymore. It's good for someone that doesn't have a dedicated server. So if you need to do stuff local, then GNS3 is probably the way to go. But if you need to do something where you have a dedicated server, I would say Eve is probably the best way to go. and then you can just pay the licensing fee for Viral's images, and then download the images, and then upload them to Eve, do the renaming that needs to be done, do the mappings. It's pretty straightforward. So that's my recommendation, is Eve. But you can do whatever works for you. If you have a laptop or a pretty powerful PC, then GNS3 is probably the way to go. The drawback to using GNS3 or anything local is the CSRs and XRV boxes take between 3 and 4 gigs of RAM per instance to run. So they're just power hungry virtual machines, and if you don't have the ability of giving 4 or 5 routers 20 gigs of RAM, then you're stuck with iOS boxes like the 7200 to do whatever you need to do. Most things, routing and switching wise, the 7200 is going to cover pretty much everything you need to do. There's nothing it can't really support, at least that I can remember. It's been a little while since I've worked on a 7200, but I typically use a CSR, and I'm running on this particular lab. I'm not using the latest and greatest code. I think I'm using, I don't even actually know what I'm using. I think it's 13.7 or 3.7. Let me just take a quick peek. So 3.17. So 3.7, okay, I remember that now. 3.17 is the release where in iOS XE is when segment routing was first released. So you could technically run segment routing, this version of code. The CCA Service Provider Lab goes to 3.14, which doesn't support segment routing. So it does support pretty much everything else. So if you want to test layer of VPLS and HTTPLS and layer 2 VPN, you need the CSR. The 7200 will do it too with the X-Connect, but it doesn't have the VFI configuration to do VPLS. At least I don't remember it having that. So, but other than that, that's pretty much it. Long, easy question, a long answer, but that's pretty much where I'm at. I don't like to leave anything to question. If I can answer it, I'll babble to get everything out that I need to get out. What's up, Kasoon? How you doing? So with that being said, let's go ahead and get. So now we have connectivity between iOS v12 and CSR1. So we know we have PE2C connectivities up, and everything is good to go there. So then what we get to go do is the same thing in CSR4. So in CSR4, if we were to exit out of the VRF config and then go to, in this case here, it's going to be gig 3. So interface gig 3, do show IP interface brief. And interface gig 3 is no shut it, and then we'll type in VRF forwarding is going to be test. Don't worry about any of the error messages you get. I only get them inside of Eve. They really don't make any difference at all. So we'll type in IP address here is going to be 10.4.15.4/24. And that should be everything that I need to worry about. Let's jump over to iOS v15. And we'll go to global config. And then interface gig 0/0, IP address of 10.4.15.15. And then no shut the interface. We'll get that in a minute to come up. And Tiello says, hi from Brazil. Well, hello, Tiello. Hopefully everything is going well in Brazil for you. Once I get done with this next CCIE, I definitely would like to pick back up the Brazilian Jiu-Jitsu that I have been studying for a while. And I know that's a big thing down in Brazil. I know not everybody does it, but it's a big thing down in Brazil, especially with the Gracies. So yeah, good stuff, man. So we'll go ahead and ping 10.4.15.4 and see if we can get a ping back. And there we go. So the pings are working, so we know everything is squared away there. So now that we have all of that, now we have to go to the next step, which is going to be the BGP VPN v4 configuration. So to do that, we don't need a route reflector in this case, but eventually I will configure one. But because it's customer one and it's pretty simple stuff, we're going to go ahead and do it. And I will then add everything that I'm doing on customer 1's router, so CSR1 and CSR4 can be replicated to customer 2 and customer 3. And then once I get done with the stuff that I want to test on customer 1, then I'll jump down to customer 3 because it's XR specific. So we will go ahead and on here we'll type in router BGP 100, and I like to type in no BGP default IPv4, which turns off the automatic peering setup of any IPv4 unicast connectivity. I don't like that. I'm kind of a control freak when it comes to that, so I don't like to allow BGP just to come spin up. I'd rather do it myself. So we're going to type in the neighbor is going to be 192.0.2.14. Is going to be remote AS of 100. And then the update source will be loopback 0. And then the address family that we're going to turn on for this peering will be VPNv4. You do not need IPv4 in order for this to work. You do need VPNv4 to work, and the reason why is VPNv4 is the process that actually assigns the VPN label to any routes that are learned from the customer in on the VRF. So we will actually hit the up arrow and type in activate, and that will bring up, once CSR4 is configured, obviously, that will bring up that connectivity. So with that being said, that's the most basic configuration you can do. I like to show it this way because then it's not overbearing or complicated, and it's, let's see here, 1, 2, 3, 4 commands. So you have turning off IPv4 unicast. It doesn't mean that it won't work. So Norman asks, do you have a training series that is purchasable, or is everything available via YouTube? So good. Actually, that's an interesting question. So right now, most things are available via YouTube. But what I am doing in the near future is I have started a Patreon site, but I haven't put any content out on there yet. I will be in the near future adding stuff there. It's a really low monthly, $5 a month, I think, and so then it'll be like anything that I put up there. You just pay $5 a month and you get access to everything. So I figured that'd be an easy way to get people to start using the content and stuff like that. Claudia, I think I'm saying that. Claudiu, I think I'm saying that right. From Romania. How is the best way to use Eve? Locally, powerful server, or Google Cloud AWS? I prefer using it locally, but I got it working in Google Cloud after a lot of effort. It took about a week of monkeying around with different stuff, but I was able to actually create you have to do this VMX thing. I forget the actual Google Cloud shell you have to do to create a VMX image. But once that's created, then you can map that to Google or to Eve, and then you have to use the Ubuntu image. Don't use 1804. Use 1604 because 1804 doesn't support Eve. Won't work on it. I was not able to get Eve working on AWS. I tried and tried and tried. Even with an AWS engineer, I couldn't get it to work. He said it would. I said, well, let me see what you do and see if it's different than what I do, and it was an epic fail. Because you need Eve requires nested virtualization. Eve, and so if you're familiar with Viral, and you're from Viral and Eve are pretty much the same thing, except for Viral costs you money to gain access to the operating systems and the licensing, where Eve is free, right? For the community version. So if you decide to go and use the Eve platform, you can run it. So you're supposedly able to run it on AWS. There's a lot of stuff that I've read where nested and hardware-assisted virtualization is supported. I couldn't get it to work, but it is what it is. So so Kasoon has a question on the subject line. Would you recommend CCISP track than going for enterprise track? Okay, so and his SP track has more dense for a person who loves routing and switching. So 2 separate questions. So they're 2 completely different tracks. 100% totally different. Can't talk. 2 totally different tracks. Having been through the routing and switching track from NA to NP, or I'm sorry, NA to IE, the SP track is way more. Basically, if you take in routing and switching through the IE and you start going down the SP track for IE, you're becoming a stronger and more well-rounded routing engineer. Because now you have to take what the customer's doing and then branch it off to other locations. So layer 3 VPN, layer 2 VPN, multicast. You really need to have those core competencies locked down. And if you're struggling with layer 2 connectivity at all, whether it's a VLAN, layer 2 VPN, stuff like that, then you're going to struggle with SP. But if you're working for a service provider, I would definitely say SP is probably a good way to go. But if you're working mostly with customers, like not service providers, then the routing and switching track would be obviously the way to go. Enterprise is going to be an interesting path because it's so. Let me provide just a little bit of clarity on this because I gotten quite a few questions about this. So the new enterprise track that's coming out, enterprise infrastructure for the routing and switching replacement, it itself is no different than CCIE routing and switching. Okay, so the bones of the exam, the 60% of it is still routing and switching. What they've done is they've added SD-WAN and SD access. So they're expecting you to be able to jump into the vManage and the DNA center and be able to deploy an infrastructure through a GUI. But before you can do any of that stuff, you need to understand how SD-WAN works. You need to understand how DMBPN works. You need to understand how Lisp works. You need to understand how VXLAN works. You need to know many, many, many more routing protocols than OSPF, EIGRP, and BGP. So those are your core routing protocols in an enterprise. If you don't know them rock solid before you take the routing and switching exam, then you're not ready. You need to lock down Lisp. You need to lock down VXLAN. And VXLAN is going to help you extend layer 2 connectivity. It's a replacement for OTV. And if you have Lisp, if you understand how DNS works, Lisp is very, very similar to it, except for it's routing. So it's a routed DNS, basically, is like the way I like to refer to it. I plan on coming out some material on that in the future. So, yeah, so I'm kind of in the same situation as you, Kasoon. I've been doing routing and switching for my entire career, and now they've added 40% of the exam is SDN. So I actually like to break this up into two separate sections. 20% is WAN, 20% is LAN. So the 20% with the Viptela side of the house, I've been spending quite a bit of time trying to learn how Viptela works and the authentication process and all the little what are the workflows that you have to go through and the certificates and who talks to who and how they communicate and all that type of stuff. It's very similar to DMBPN, not one for one, but there's similarities, and but they're not. But DMBPN is a routing technology, right? Where SD-WAN, which is what Viptela is an application routing. So it's looking at the application itself. But you need to in order to get the endpoints to work, you need to be able to get through the process of whatever their workflow is. I'm still trying to figure all that stuff out. There's actually a pro image of Eve, I think that's the latest version right now, supports all of the Eve images. So my goal is in the near future is to get the pro version, upload the Eve images, the Viptela images to Eve, and then play with that in a virtual environment. Although the way that Viptela was rolled out, because I had a few minute conversation with the guy that actually developed the Viptela routing protocol, OMP. His name is Khalid Raza. Really, really, really smart guy. I felt stupid asking him some questions. But I was like, hey, I need to understand something. And I said, I need to understand, can I roll this out in a private environment where I have zero internet access, period? And he goes, yes, it's easy to do. There's more hoops to jump through. Because normally when you deploy Viptela in production, you have the vBond, which is the first device you connect to, is publicly accessible. So you basically have to tell the vEdge what vBond to go talk to, and you tell it based off of a configuration, and it's a DNS lookup. So it goes out and finds out what IP address to go to, goes to the vBond, and then from there, it goes into vManage, vSmart, and I think there's I forget what the other one is. There's another piece that's, or it could be orchestration. I don't remember. I'm still trying to learn it all, and I'm by no means an expert. But once you've gone through all of that, then you're in good shape to go through and start putting the SD-WAN piece in. To me, they're two separate things, but they can work together depending on the design. But in my opinion, whenever you're approaching a CCIE, you need to approach it per technology first. So assume that you're studying CCNP for one thing I wish that they would have done, and I'm trying to talk to them about adding another exam for SD access, because I think that's needed because it's such a large topic scope in my opinion. So they've got the advanced routing for the new exam that's coming out beyond the core, and then they have the SD-WAN exam and then the design exam. I think they need to add a third, which is SD access, because it in itself is you're dealing with Lisp and VXLAN. Now, routing, understanding the technologies isn't that much of a stretch, right? But in order to understand how SD access works, you need to understand how Lisp and VXLAN come into play, and then the automation and assurance piece, the DNA center, comes into play. Then you have ICE for doing the policy enforcement with secure group tags and the VNs and stuff like that. So it gets very involved. If you just dive into the CCA Enterprise, or the replacement for routing and switching, I see a lot of people falling flat on their face. And I don't know exactly how they're going to go about doing that, because now, as far as I know, DNA Center is only a physical box, and you need DNA Center to roll out SD access. Going based on everything that I've seen at Cisco Live, that's all the demos I saw. That was everything that they were doing. And they had this massive server with these unbelievable amounts of resources. So I don't know how that's going to get delivered. They've got 8 months or so before they have to have that figured out, which I'm sure they already do. But pretty good question, really long answer, but that's pretty much been my trying to understand how all this stuff is going to come into play. But there's a lot to it, and I'm right there in the mix with you soon, because being on the instructor side of the house now, I have students all the time asking me, well, how do I go and figure this out? What are my steps that I have to go through? So you're not alone in that. I actually see a lot of these Cisco communities asking the same question. So, but with that being said, let's go ahead and continue where we were going from. But if you have any more questions, feel free to ask them. Let me go over to CSR4 and get him squared away so we can get this layer 3 VPN up and running. So we'll do router BGP 100, no BGP default IPv4. Now, I could have copied and pasted out of CSR1 over to CSR4, but it's not that many lines of config. Update source is loopback 0, and address family VPN v4, and then activate. There's another question. One question, should I go for CCMP now or to wait for the new version? In your opinion, is CCMP doable in 7 months? That's kind of a stretch. Depends on where you are in your CCMP journey. If you've just starting CCMP, no, I don't think it. Unless you have a massive amount of time to dedicate to CCMP, I don't think it's doable. It took me about 9 months, and I was studying every day, probably 2 or 3 hours a day. But if you have the time, and depending on where you are, if you've already done route and switch and you only got T-shoot left to do, hey, yeah, completely doable. But if you're just starting out, I would say learn the material on the CCNP, because when the new one comes out, it's gonna be interesting to see exactly how that plays out. But I definitely would say don't stop studying. Continue to do so, because a lot of the material that's on the current blueprint is going to be mapped over to the new one. But they're adding some things like virtualization and some other stuff. But I think what I'll do is I've actually already recorded the videos for them. But I think what I'll do in a day or so is I'll do another live stream where I'll have the Cisco certification updates, and then I'll let you guys just jump in and start asking questions and go from there, because I think that'll be important to understand how all that comes into play, and we can figure out all that stuff together. But if you're currently a CCNA and you're working on CCNP, I think it would be a good idea if you can get CCNP done today or before the new exams change over, because the folks that do the new exams before they have the certifications knocked out before the new exams start, then the new you'll get more out of it in the long run. Instead of just getting a CCMP and routing and switching, you'll get the CCMP Enterprise. You'll get a bunch of badges. You're technically be dual CCMP at that point, because then you'll have the routing and switching, and you'll have core with the specialization and whatever, routing and switching, and there's some other badges. I'm still waiting on Cisco to give me some feedback as to what that badging is going to look like. But there's actually a lot of really cool stuff that they're doing for you. They're making it much more modular, which I think is really good. So, and it's only 2 exams now. If you wait until the February 24th and go take the CCNP exams, then it's 2 exams, not 3. I don't know the price of those because they haven't dropped in Pearson VUE yet. At least the last time I checked, they hadn't dropped because they're not schedulable yet. But it's 2 exams. But there's more stuff that they're throwing at you. So there's a little bit of programmability, a little bit of automation that you need to understand, and that's stuff that I have to go learn. So, because I've never really been that guy. So hopefully that answers your question. But I'll definitely, I think I'll need to do a live stream or some sort of content on that in the future. I wasn't planning on doing it, but you guys are asking a lot on the new stuff, so there's interest in finding out. So good questions. Keep them coming if you have them. As it is right now, we have our BGP peering up and running between CSR1 and CSR4, so we'll go ahead and just verify that. Show BGP, VPNB4, unicast all, and hit the enter key. You'll notice that nothing shows up, and that's because there's no routes have been learned. If we hit the all in the summary, hit the enter key, and you'll see that I've got a peering up, but there's no prefixes received. So pretty straightforward from that. Now what we have to go do is the very last step. And this very last step is going to be the PE to CE routing. And I'm going to use my favorite routing protocol of all. You guessed it, BGP. So on CSR1, we're going to... Sure, Claudia, I'm glad I was able to help. So router BGP 100, and now that we're under BGP, we need to type in address family IPv4 VRF test, and underneath here we need to specify neighbor of 10.1.12.12. Remote AS is going to be 65001 per customer 1, and that's all we have to do. And then because it's customer 1, and I'm going to have both IOSV 12 and IOSV 15 in the same autonomous system number, we'll cover that in a minute, because I've seen a lot of people fall flat on their face when they don't realize how BGP works when it comes to AS path protection. So we'll take a look at that here in just a minute, and why the routes won't be actually passed. So I'm back on IOSV 12. If you already know the answer to how to fix the AS path protection issue, you can go ahead and comment below or in the chat, and we'll see if anybody knows the answer to that. There's actually 2 ways of doing it. If you know one or the other or both, toss them in. If you're not sure, you can ask the question anyway, and you'll find out the right way to do it here in just a minute. So router BGP 65001, and then no BGP default IPv4. We'll type in neighbor is going to be 10.1.12.1. Remote AS is 100. And then address family IPv4. And then activate. We need to activate the IPv4 address family because we are not running VPNv4 here. So momentarily the peering will come up, which it does. And do show IP interface brief. Now I don't have any advertised routes here. So what I need to do, and now is type in network of, in this case here, I'm going to do a 10.100. Or 10.1.100.12, or no, 10.12.100. and /24. So you might say, okay, what is that supposed to be? Well, the 10.1 will be customer 1, the router number will be 12, and then the 4th octet will be the IP address locally. So, and then the mask command. And let me go ahead and .0. I'll type in interface loopback 0, and the IP address is going to be 10.1.12.100 /24. Beg your pardon? 10.1. Oh, yeah, I was an idiot. I can't do that. So we'll say that, let me do I can't do that. I was a moron on that one. We'll do customer 1. We'll do 12. Whoop. We'll hit the up arrow. We'll do a 12.1.100, and then we'll just have to go back to router BGP 65001 address family IPv4, and then hit the up arrow a couple times and say no to this. Whoops. No to this. The up arrow, pull that out, and then do the 12.1, and that should fix that problem. So there we go. All right. So going quite well. Another question. I'm building a dedicated lab server and thought 128 gig of RAM would be enough for all possible training scenarios. Is this overkill? What would you recommend as a minimum for CCMP Lab Server? Funny enough, I don't know if it's on. Am I on that box? I am on this box. This server that I'm running currently has 128 gigs of RAM. It's running Eve. It's actually running a couple of versions of it. I have 2 different versions of Eve running, or sorry, 2 different instances of Eve. Plus, I'm running Windows 7 for GNS3, which has 16 gigs of RAM, but isn't really doing a whole lot. This guy right here is pretty much dead. It's actually this guy right here. This is going to be unified MPLS. So overkill? Absolutely not. Let me go back to this guy. If we go back to this, it's a little slow, but as you can see, CPU-wise, I'm doing great, right? But on memory, I'm pretty much tanked. I really can't go do a whole lot more on this. I've got about 6 gigs of RAM that I can play with if I wanted to, but I don't really have the luxury of adding any more to this if I wanted to. But it is what it is. So if you can get a 128 gigs of RAM on a server, this is a UCS C220 M3 with an E5 2620, 2 sockets, 6 cores per socket. So with hyperthreading, it's 24 logical processors right here. So it's pretty beefy. I bought this about 2 months ago, 3 months ago. One of the best decisions I ever made. So if you have the ability to do it, by all means, go get it. It'll actually leverage a lot for you, because then you'll be able to do things like VMware and run servers and stuff like that. And if you get access to run ICE and Call Manager and all those other types of stuff, that'll come in handy too. So if you have it to do it, absolutely take advantage of it. I always do. I always find myself running out of resources on servers and testing out things. So that's why I have 3 different Eve instances running. So this will be inter-AS once I get done with a little bit of stuff that I have to do on intra-AS. This is my inter-AS topology. This is my intra-AS topology. And then I have unified MPLS. So I'll be testing that out. And then all the layer 3, layer 2 VPN, multicast VPN. And then I'll be doing Lisp and some VXLAN. It's still in process or in progress, but it's a work in progress is what I meant to say. I'm talking too fast. So with that being said, let me go ahead and jump over to CSR1 and do show BGP VPN-v4 unicast. Can we configure MPLS without the need of yes, you can. And actually, it's so unicast all. So let me separate your question. You actually have 2 separate questions. Or I'm sorry, 2 different technologies, not 2 separate questions. So MPLS actually has 0 to do with BGP. MPLS is just a labeling technology. IPv4 unicast does not need to be turned off, but if you look at my configuration, I do not want to accidentally, and once you configure this right here, this line of config, if you don't disable IPv4 unicast on both sides, they'll form both address family peerings. They'll form a peering with IPv4 unicast, and they'll form a VPN-v4 unicast. So what I'm just demonstrating here is you don't need IPv4 to be operational in order for VPN-v4 to work. You can have both operational at the same time, because you might have a PE router that's doing both internet access connectivity and customer VRF connectivity through a layer 3 VPN. So you can do both at the exact same time. So what's really the need of it? So if I so if I don't want to form a IPv4 peering, then I would turn that on. Now you could just type in no underneath the no neighbor underneath the, like I did under the VPN-v4 config, where I can just blow away the address family. That's an option for you, but commonly I don't run both at the same time, so it's nothing to do with IPv6. No, nothing at all. So actually, I'm glad you asked that question, because it's they're all separate address families, right? Each one is you have your AFI and your SAFI. So you have your AFI is going to be IPv4 or IPv6, and then you have a bunch of subsequent address family identifiers. Unicast, multicast, VPN-v4, VPN-v6, MDT, MVPN, so on and so forth, for both IPv4 and IPv6. If I was to go exit out of here and type in address family IPv4 and do a question mark, these are all the different address families that I can enable BGP for. Same thing with IPv6. IPv6 and question mark, same thing. So the only difference is that IPv6 does not have an MDT, it does have an MVPN. So other than that, those are the only major differences. So you don't have to have the address family running in order for it to work. Although there are some instances where you would need it if you're running like regular internet traffic through it or regular IPv4 traffic, but not labeled communication through an MPLS backbone. If you're running MPLS in the core and using VPN-v4 between the provider edges, you need VPN-v4 because that's going to be the mechanism that assigns the labels to the customer learned routes. I hope that makes sense. And to reaffirm that comment, if we do a show BGP VPN-v4 unicast all, and then we go ahead and we grab this particular prefix and we copy and paste it in. Notice that right here, with the MPLS labels in, you see 53 is applied, right? That shows me that that VPN-v4 applied label 53 to this particular prefix. So when we do a trace route to the core, you'll see the label value, the VPN label value of 53 across the wire from CSR1 through CSR4 until it gets to CSR4 and gets popped, which if we go to CSR4 and show BGP VPN-v4 unicast all, we're going to see this. And if we do a show MPLS forwarding table, you're going to see 53 doesn't pop in here yet, right? 53 isn't propagated, and the main reason why is because there's no routing adjacency on the remote end. So what we'll do, if we do a show BGP VPN-v4, or no, it's BGP VRF so Muhammad asks, why you use iOS XRV 9K and CSR? Can't use Dynamips? What is differences between XRV 9K and CSR? A huge difference between the two completely different operating systems. So Dynamips can do some things, like if you're in the routing track, routing and switching, it can do a lot of your routing stuff. However, if you're doing anything on the service provider side of the house, iOS will do some things with MPLS, like it'll actually allow you to do a lot of LDP stuff. But if you want to do anything advanced, like advanced traffic engineering, or do anything advanced with VPLS, HVPLS, PBB, EVPN, any of the advanced layer 2 VPN technologies, it doesn't support any of that. So CSRs are going to be the equivalent to the ASR 1000 platform, which is commonly deployed as a provider edge router. Deployed those several times. XRV 9K is going to be the equivalent to the ASR 9000 platform, or the NCS 5000 and 6000. And those versions of code are going to be what service providers use in the backbone. So without going into a long dissertation as to the differences between the two platforms, that's why I'm using both. XRV and CSR are going to be the iOS XR and the iOS XE version virtual machines that you can use to test out all the different service provider technologies. So VRF test, and then VPN-v4 unicast So here, we see it here, and if we go and grab this particular prefix, you can see the out label is 53. So going back to what I was talking about in the previous point, here we have it going outbound on CSR1. We have it, the in label right here is 53, but on CSR4 and the out towards the VRF it's 53. So that's why you see that. So it'll be 53 across the wire, but being able to pinpoint those using show commands without having to do a trace route, if you can do that, then that proves that you've spent a lot of time on the verification side of the house and you understand the flow of how MPLS works. So let's go ahead and get this configuration going for, let's see, do show IP VRF IP route VRF test. And I already have a BGP peering up there, which is awesome. So now I get to go over to iOS 15. And so on router BGP, well, actually let's do it this way. Do show IP interface brief. Let me create the loopback interface first. So interface loopback 0. IP address is going to be, and what did I use for iOS v12? I used 10.12.1. So I'll do the same thing over here. So I'll say 10.15.1.100/24. Sure, no problem, Mohammed. Glad I could answer your question. So router BGP 65001, and we'll type in the address family of IPv4, and then the network of 10.15.1. Sorry, 10 dot, and then 0 mask/24. And so now I'm going to be propagating this route into the VRF table. So now CSR4 should see this route. If I jump in here and do a show BGP BPNB4 unicast all, now I'll see momentarily, once the route gets propagated, I should see this route show up in the routing table. So let's see. Show BGP IPv4 unicast neighbors 10.4.15.4 advertised routes. Show run section BGP. Oh, haha, okay, that's part of my problem. Router BGP 65001. Neighbor of 10.4.15.4 remote AS of 100. Yes, I did not actually, so that should form an adjacency pretty quick here. And once it does, we should, unless 4 has been show run section BGP. Oh, I didn't do it on this side yet either. So sorry. That's what happens when I start answering questions. I get sidetracked. So router BGP 100 address family IPv4 VRF test, and then we're going to type in neighbor of 10.4.15.15. Remote AS is 65001. No problem, Norman. I'm glad I could jump on those for you. So that'll get that peering up and running here momentarily. So as soon as that peering is up, which should happen momentarily, then there it goes. So that just goes to show N71. If we do show run section BGP, I did not disable the BGP IPv4 unicast automatic configuration. I did not disable that, and you saw how I didn't have to actually your responses, no worries, man. I didn't have to activate the address family. It automatically did it by itself, and that's what I was turning off on the provider edges. I turned that feature off because I didn't want it to run. So now we have that going. Let's go back over here on this side and show BGP, and here we have the learned route. So everything's working there. Now, if I go to CSR1, I should see the same thing, right? Right, it propagates. That's working. Now, if I go to iOS v12 and I do a show IP route, oh no, show IP BGP. Oh no, Why is it not showing up? Any ideas? Any ideas at all? Let's do a show IP BGP summary. So I haven't learned any prefixes from the provider on either side. Do show IP BGP. Nothing at all. All I'm seeing is my locally propagated route. And you know it's locally propagated because the next hop is us and the weight is 32768. So I'm not seeing anything coming across. If you run into this problem, which I have seen many an engineer do, especially when they're setting up layer 3 VPN with private autonomous system numbers, this is a common problem. So the simple fix to this problem is to either disable the AS path check capability on the customer side, or to disable it on the provider side. So on iOS v12, I will go ahead and configure it on the customer side, which is really, really easy to do. And on CSR4, I'll show you the provider side of the configuration. So here, router BGP 65001, and then underneath address family IPv4, we'll type in neighbor of 10.1.12.1, and we'll type in allow AS in. With this command, you're basically saying, if I receive an update in from the provider with my locally assigned or created autonomous system number, in this case here 65001, I'm in that autonomous system number, so technically speaking, I am receiving an iBGP update, but from an eBGP peer, so I'm going to drop the update. So if I type in do show IP BGP, now I will receive the route, right? So, but does that fix the problem on iOS v15? Sure doesn't. The problem still exists. So now what I need to go do is on CSR4, underneath the VRF, type in router BGP 65001, and, 100, and then underneath address family IPv4 VRF test, type in neighbor of 10.4.15.15 and use the command AS override. AS override, and I can do split horizon if I wanted to, but I'm not going to dive into that at the moment. If I type in that command, I'm saying, you know what? I want to propagate the route from me down, so CSR4 down to iOS v15. Man, that dog is loud. What'll end up happening is the provider will actually replace the AS path, the customer autonomous system number with its own AS number. So eventually the route does come through. Now if you look on iOS v12, you'll notice that I have a 100.65001, which is, this is the originating AS, this is the provider's AS. If you look in iOS v15, you'll see that I have two AS 100s, because this one right here, which is the originating autonomous system number, then I know that the provider said, you know what, let's swap out 65001 with AS 100, and so that he'll be able to receive it. So now the real question is, can I get end-to-end? So let's do a ping to 10.12.1.100, sourcing from loopback 0, and you bet your bottom dollar I can. So now if I was to do the same command, but let's do a trace instead, and then go to here and numerically, oh, can't go to me. Ha! What did I do? I pinged the wrong IP address. So that happens. 15. So I can still ping that. Let's go to here and go to the end and type in numeric. And I can get there all day long. So that's basically how that comes into play. So now you might say, well, Rob, how come the MPLS label here is different? Well, that's the wrong side. So I need to go over to 15 and do the same thing. So ping 10.12.1.100 source loopback 0. I can ping that. Let's do a trace. And numerically, notice how it's got 53. and that's because it's going the opposite direction. So that's basically how that comes into play. So now if we were to go look on CSR1 and do a show MPLS forwarding table, guess what we have in the routing table now? Now we have 53 is in here, and we know it is reachable out the next hop, but my there's no label here. This is just the BGP label here. It's applied. 53 is applied, and this is going down towards IOSV 12, or in this case here, it's going that way. So that's basically why that comes into play. So that's the layer 3 VPN piece. So pretty straightforward for the most part. Nothing too terribly complicated about that. So does anybody have any questions on anything that I covered there? I know it's been a little while now, a little over an hour. It took a few minutes to get up and running and to run through the initial configuration, but and I'm watching the stream, so I see it's about a 10-second delay. So if anybody has any questions on anything that I've covered, I will be happy to give any type of clarification. If not, I will go ahead and start the layer 2 VPN portion and then go from there. So can you please repeat when you get the active automatically? Sure, no problem. So on CSR4, do show run section BGP. And notice how underneath here, well, it actually probably would make more sense on the customer side. So on IOSV 12, so here I've turned off the automatic need, so I have to actually go configure the actual activation here. So if you turn this, use this command and you type in no BGP default IPv4, which is the automatic spin up of an IPv4 peering. If I turn that off, I need to explicitly turn on the peering. I need to activate it because BGP by default, once you turn this off, actually I should say not by default. Once you turn this off, you need to manually enable the peering. One moment, please. Sorry about that, ladies and gentlemen. The wife called. So, let me finish answering N71's comment or question. So by turning off this, you need to explicitly enable the peering. Now on the other side, on IOSV 15, show run section BGP. Here I did not turn off the automatic IPv4 peering capability, and I did not need to turn it on. It just did it by default. Since you need the activate command, why from the beginning you put no? So So that was just a demo. So N71. The reason why I did that was just to demonstrate that you didn't need the IPv4 address family. That's it. Nothing. There's no like sneaky CCI router trick behind the scenes. It's just to prove that I don't need it there. So Muhammad asks, when you live stream, do you schedule it before it? I was planning on. I wasn't actually planning on live streaming at all, but it just happened to work out to where it was. Uh, I did it, and I've had a pretty consistent viewership since I've gone live. So that's pretty much it. That look on your face, is that a possible troubleshooting? No. I recognized the picture as soon as it came up. That was my wife, and I had to answer the phone. I figured a minute pause would be okay. But so yeah, normally I would just mute it, and then in the recorded video I would just edit that out. But you guys are cool about that. So with that being said, I hope hopefully N71 I've answered your question. It might be a new concept to you, maybe. To me that's what I'm interpreting. If it isn't, that's cool too. But you don't have to turn it off. But if you don't turn it off and you type in the command on both ends, IPv4 will automatically form on iOS as well as whatever address family you enable. Just make sure you're aware of that. So Norman says, this is all new to me presently. I actually work for a SP and trying to move forward past my CCNA cert to the CCMP. Cool. I think that would be a definite move in the right direction. So yeah, well, no problem. N71. I'm glad I'm able to answer that. I like it when people ask until they thoroughly understand. Because if I'm one of those type of folks where it's a crawl, walk, run to me. If I'm already at run and near breakneck speed sprint, so to me I'm like having to slow down to walk through this stuff. But this is why I think instructors need to be, or at least solid engineers need to be able to break this stuff down and answer questions to anybody, really put it in layman's terms, so you should be able to answer it. So I try to do a good job when I train. Anyway, but I enjoy this stuff. So normally I don't ever get any interaction, so I'm automatically assuming that everybody gets what I'm saying, even though you might be like, huh? But all well. I got confused since we need to activate the neighbor either way. Can we configure BGP without the no command? Yeah, you can, and that's exactly what I did on 15. You don't need to turn it off, right? So I don't have it turned off here. But if you don't disable the no BGP default IPv4 unicast, as soon as the routers communicate with each other, then they automatically form the peering. It's on by default. So if I was to do a show run all section BGP, and I don't know where it's at exactly. I'll have to scroll for it real quick. Let me go to the bottom here. So if we go underneath here, it's on by default right here. And this is BGP policy. So right here, it's automatically going to be on. So it's part of the default configuration of BGP. So if you do not want an IPv4 peering to form automatically when you configure just the neighbor command under the global BGP peering configuration, which is this right here, if you do not want it to form, you need to turn it off and then activate it manually. If you don't care, then don't disable it, and it'll automatically form a VPN-V4 or IPv4 peering. Hopefully that makes sense. So other than that, that's there's no wizardry behind the scenes. It's one of those things where I've worked in service providers for a while, and you need to understand how that comes into play. But other than that, hopefully that answers your question and provides a little bit of clarity for you. But so with that being said, the next step is going to be jumping into the layer 2 VPN, which is even more fun. And no, pardon me. Yeah, no problem, N71. I don't know what your real name is, but that's actually a cool screen name. I actually like that one. It's very unique. Instead of just a person's name, N71. I can only imagine what that actually stands for. But the layer 2 VPN portion that we're going to start out with is just going to be the flat out X connect. I don't know if it's only me or video becomes a little blurred. Yeah, you know what? It's actually on my side. I keep getting these warning pop-ups that the bit rate is too low. And I'm not exactly sure how to fix it. But it's going through an ASA. I have an ASA 5520, and I've got 20 megabits up, and I'm looking at the kilobits upstream right now, and it's telling me I've got 2600. So it's like I'm using the full bandwidth capability of my firewall. So, Newer, born in... okay, that makes total sense. Okay, so your first name is Newer, and you're born in 71. Okay, so you're a little bit older than I am. That's cool. Awesome. So, yeah, if you guys notice it gets really blurry, let me know in the chat, and then I can maybe do something to fix it. But my router died a couple months ago, so I've been on an ASA ever since. So I don't know what the bit rate needs to be, if it needs to be higher, but I don't know. It seems to be pretty good. Normally I record at 1080p. Yeah, it is what it is as far as I'm concerned. But anyway, so layer 2 VPN. We'll start off with the X-Connect aspect of it first. And so Savat. Hey, no problem, Savat. I think or Savat. Your name is really hard for me to pronounce. So, yeah, thanks for that. I appreciate it. So we're gonna do the X-Connect configuration on the CSR and the CSR1 and CSR4 to get a peering between, or to be able to ping layer 2 VPN, and then we'll dive into the layer 2 construct. Now, here's one thing that I'll talk about real quick, is if you have a situation where you've got, for example, you're doing one router, or two PE routers, then point-to-point layer 2 VPN, whether it's virtual private wire service or some other variation of that, that will work just fine. VPLS could still work. However, it's going to be VPLS designed for a multi-point to multi-point, so 2 or 3, or 3 or more devices. So, but and something was sorry, but it's hard to see the configuration. So you need it to be bigger, maybe. I don't know if I can make it bigger. Let me see if I can't bump that up for you. Sessions. Nope, that's not the one I was looking for. Let me go here and... Why is it not letting me work? There we go. So, change settings. And I'll bump the window appearance up to... Normally that's pretty good, but... let me go to terminal, and we'll go to... No, what was I on before? I forget. I was on Lucidia console, so I'll jump up that to 20. Maybe that'll be easier for you guys to see. Apply. Oh, that didn't apply to all of them. It just applied to that one. So, okay. Don't know how to fix that. As soon as my wife called, the video became very blurry. I can blame it on my wife. I like that. That's... I don't know how to fix that. There's really no way for me to do that. But... Oh, wait a minute. Did my... Oh. Let me go out of the stream, maybe that'll help a little bit. And then it won't be picking up it'll just be picking up the screen. Let me try that. But you can still ask the questions and whatnot. Hopefully that'll that'll fix any of the issues that I might have. Hopefully that'll become easier to see. But we'll go from here. So the XConnect, okay, video quality. Okay, so some other folks are saying that the quality looks pretty good. So it might be local to you. Okay. Yeah, I wasn't sure, to be honest with you. It's hard for me to tell. Although I do appreciate you guys letting me know that the audio, the video is good, because I'm looking at the video stream. I'm like, I can't do much better bit rate wise. So I'll come back in and say hi. So it's only me. So sorry, man. You can probably watch it in the recorded format. I appreciate that, man. I do. So on the, instead of babbling about it, let's actually go through and do it. So let me just break down something real quick on the XConnect. The XConnect is the oldest, at least the oldest way in my opinion, or my experience, to do layer 2 VPN. And when you do it, you actually have to go and configure the XConnect underneath the attachment circuit, pointing towards, in this case here, it'd be going from CSR1 to CSR4, and go from there. Presently, this has the feeling of a virtual classroom showing. Yeah, it's kind of that way. I like to interact. I'm thinking I'd like to do more and more of this, because then you guys are more interactive. But yeah, I like this because then you guys can ask questions. So no worries, N71, all good, brother. So what I'm going to go do is on CSR1, I'll go ahead and get this guy rolling. So underneath gig 5, so do show run interface gig 5. I actually had already started playing with this a little bit. So I'm actually going to say default interface gig 5. So Lawrence says current stream is 1920 by 1080 at 60 hertz and looks good. Thanks, Lawrence. Thanks for the update, man. I appreciate that. So now I've gotten rid of all my config. Let me just do a quick show run section sudo and L2VPN. Get rid of that stuff real quick. So I was already playing around with this a little bit. I spent a lot of time on layer 2 VPN. And we're going to pull this guy out to the layer 2 VPN context. So we'll have a blank canvas to play with here. So I don't know where you guys are at with your layer 2 VPN connectivity, but I'm going to start out with the basic configuration, and then we'll work into the more advanced CLI options with the layer 2 VPN CLI, with the pseudo wires and doing the context and stuff like that. It makes it more scalable and easier to work with, and you'll see why. I'm actually going to show you some of the error messages so you guys get to see what that looks like. So interface gig 5, we'll come in here and we'll say that on the XConnect itself, you have to specify who you're going to talk to. In this case here, it's going to be CSR4, so 192.0.2.4, and then we're going to specify the VCID. I'll give it a 1 because it's, you know, the first one. And then we'll specify the encapsulation is going to be MPLS. Pretty straightforward stuff. There's a few little things like you can have a backup configuration and you can modify the MTU and stuff like that. Not too much to worry about there. So on the other side of the house, we're going to go and go to CSR4, and on gig 4, show IP, as soon as it wants to respond, interface brief. Gig 4 is currently down, so we'll type in interface gig 4. Oh, and the other thing on CSR1 is you have to actually exit out of the XConnect configuration in order for the XConnect to come up. If you stay in the configuration mode, it's basically sitting there at idle, like, okay, what are you going to type in next? Come on, come on, come on. And then as soon as you exit out, it goes, okay, process can start, and off to the races we go. So CSR4, and then we'll type in no shut to bring up the interface. And we'll type in the XConnect command, and we'll specify that 192.0.2.1 with a pseudo wire, or the virtual circuit ID of 1. And this has to match on both ends. The virtual circuit ID is pretty much the pseudo wire information, and the label bindings and stuff like that come from there. So the encapsulation will be MPLS. Hit the enter key and then exit out. And that, ladies and gentlemen, is it. So that we have the pseudo wire 0 comes up. So it's an automatic creation. You don't have to do anything about that. And then we have a targeted LDP peering with CSR1, and CSR1 says the exact same thing. As a matter of fact, it's a little hard for me to Let me actually edit the session real quick, because that's a little too big. Let me jump back down to 16 point. 16 point seems to work quite well for me. Sorry, N71. Sure, Hanan. If you have any question, if anybody has any questions at any point, just type them in and I'll answer. I do see it pop up, so if you have any questions, feel free to ask whatever questions you have. So there we go. So now we have that up and running. And if we jump out of global config, we do a show MPLS. Let's see, LDP discovery. Is it this one? Yes. So right here, we have a targeted peering, and we didn't actually configure anything to do this. It does it automatically for you, where we have a targeted hello going from CSR1 to CSR4, and it's active, passive, and it's transmit and receive, which means it's going to send and receive traffic at the same time. So that's going to be basically how we get the layer 2 VPN portion operational. Now, that being said, because we did an X connect, we're assuming that the traffic is going to be main interface, which is also VLAN 1. So on iOS v12, if we jump in here and we do a show IP interface brief, we look at gig 0/1, which is our main interface. Gig 0/1, let me go ahead and change the IP address here to be interface gig 0/1, IP address of 10.12.15.12/24. And we'll type in router EIGRP1 network of 10.12.15.0.0.0.0.255. Now what I'm doing here, just so everybody's aware, is by me configuring the IP address on the interface and then enabling EIGRP on the interface, as soon as EIGRP has communication through the backbone, the adjacencies will come up, which will prove that we have the customer edge to customer edge connectivity is being basically bridged via a point-to-point pseudo wire between CSR1 and CSR4 between each other. So on CSR4, or I'm sorry, iOS v15, if I could ever say it right, we're going to go to interface gig 0/1, and IP address is going to be 10.12.15.15. We're going to no-shut that interface. And then we're going to go underneath router EIGRP1 and type in network of 10.12.15.0.0.0.255. Now, if I've done everything correctly, what should happen is I should be able to ping, and then shortly an EIGRP adjacency should form. So it might take a couple of minutes for this to actually kick into play. Let me check on CSR4. And so the peering is up that way. Do show IP interface brief. Do show run interface gig 4. Make sure all that's looking good. That is correct. So that's looking good. iOS v12. Let me see if I can't ping across the wire. So let's see. So Mohammed has questions. To change font for all sessions. Oh, hey. Is that an option here? So I think that's secure CRT there, Mohammed. Global options general. Yeah, I don't have. It's just in secure CRT. It is. I can go to. You say options, and then global options. Yeah, that's secure CRT. I'm using Super Putty for this specific one. I'm using secure CRT on this topology. So that's where this one comes into play. Secure CRT is going to this guy. So thanks for the help, though. I appreciate that. So, and what we're going to do is ping 10.12.15.15 and see if we don't have connectivity. And currently we do not. So we might have some connectivity problems, and we have to figure that out. So on CSR1, let's go see why we're not doing anything. So show run interface gig 5. So it is up and running. And if we do a show MPLS forwarding table, we have a layer 2 circuit. Yeah, exactly, secure CRT. So we have this point-to-point connection here. But for whatever reason, it's not coming across, and we don't know why, right? So Let us start diving into figuring out why it's not working. So let's do show MPLS LDP discovery, and that looks good there. All good, Mohammed. So iOS 15. So this should be working by now, and I don't know why it's not. So let me see here. Let's do a trace route to 192.0.2.1 sourcing loopback 0 numerically, and I am a labeled path all the way there, which is exactly what I would expect to see. And oh, wait a minute, hold on a second. 9. I'm taking that path. Okay, 9. Okay, that should work just fine. So it's not working. Why is it not working? So show run interface gig 4. That's up and running. No IP address. Encapsulation is MPLS. So let's do a show L2VPN atom, and we're going to specify the VC is going to be, the VC ID will be 1, and we're going to hit the enter key. So it is up and running, and if we look underneath the detail, let's take a peek here. Let's see why it's not actually working. So it's Ethernet, which is exactly what it needs to be. We have a label stack of 52 and 24,004, which gets us to the next hop. And it is not working. So I suspect that this might have to do with a licensing problem. Now let me explain why I'm going that direction versus a configuration or a lack of support, which it probably is. So one thing that I did not do on these routers was I didn't go and activate the licensing. So we do a show license and what is it? Show license. So these are all the different licensing options you have. If we do show license and status, we grow up to here with the different licensing types. I'm using the IP base license. So if we were to go to global config and type in license, boot, level, and you have all these, by default it boots up with IP base. But if you wanted to do like application experience, security, and all that type of stuff, you could individually enable those, or you can do AX. In this case here, AX is, which is weird. I'm not 100% sure that it's a licensing problem because I did this configuration between these two boxes before and it worked. So I'm like, I have a problem and I don't know how to fix it. So you know what I want to do? If you want to Google Xconnect and see how it works. There's plenty of other people that have demoed it. I'm going to not waste my time trying to figure that out, waste your time. I'm going to go and play around with the CSRs with the non-Xconnect version, which is the way you should be doing it anyway. It's more scalable. Especially with Ethernet flow points and Ethernet virtual circuits, it's easier to work with. So what I'm going to go do is show run interface gig 5. But the configuration is correct, right? So I'm going to come in under here and type in no and pull this out. Give it a second for it to respond. So that'll take down that, and now I'm going to go over to CSR4 and do the exact same thing. And we're going to specify that, oh, you know what? Hold on, let me just double check something real quick. On iOS 15, show IP interface brief. Okay, I just want to make sure that I didn't have an accidentally shut down interface and made me look like an idiot. But I do that enough without trying. Do show run interface gig 4. Oh, and I believe Mohammed just sent me Mohammed just sent me a invitation on LinkedIn to connect. I will accept that invitation as soon as I get done. So thank you for the invite, by the way. So no Xconnect on that guy. So what I'm going to do is I'm going to move over to the layer 2 VPN option, which is, I think, a cooler way of doing things, and more scalable. So back on CSR1, instead of doing it the way that we're doing it here, we do it the cool way, in my opinion. So we're going to type in service instance not service insertion, service and then instance. We're going to specify the first one here is going to be 1, and we're going to specify that it's Ethernet. And underneath here, we're going to specify the encapsulation is going to be default. So we're going to say catch everything. We don't care what it is, just catch it. And then underneath, we'll exit out of here. We'll exit out of here. Now we have to configure something else, which is going to be the pseudo wire. So interface pseudo wire, and the pseudo wire is going to be 1. And then we're going to specify the neighbor is going to be 192.0.2.4, and we have to specify the circuit ID of 1, and now we'll specify the encapsulation is MPLS, and the signaling protocol will be LDP. Now, a lot of this stuff is going to be redundant information. I type it in just because I don't want to forget how it works. And then we're going to go and say, now we have the pseudo wire, which is going to be a point-to-point pseudo wire between CSR1 and CSR4. We're going to say that the L2VPN and then the XConnect context, and then we're going to give it a name. We're going to say 1 to 4. 1 to 4, and we'll get rid of this guy. 1 to 4. And underneath here, we need to specify who is going to be peering. So what we have to do is we have to join the attachment circuit and the pseudo wire. So N71, sorry if you answered this question. I joined late. I want to put the diagram on my Eve. Can you please share the diagram? Also, which routers are you? Yeah, I'll. I can't share the UNL file. Maybe I can build it in another Eve instance that's not running. But I'm using CSR's 1000V's 3.17 code and iOSXR 6.0 code, if that helps. So those are the two router platforms that I'm using. And then I'll try to replicate this inside of another UNL file, and then I'll upload it, and it'll be like a Dropbox file, and there'll be a link in the description. So that'll be how we go about doing that. So now we have to specify the member, and we'll specify that the gig, in this case here, is going to be gig 5, and then the service instance that we want to apply to this is going to be 1. And then the other member is going to be the pseudo wire and pseudo wire 1. And then if we hadn't already configured the pseudo wire, we could specify the neighbor and then the encapsulation that goes along with that. But that's all we have to do. Now we have to exit out of this, and then that will start the actual construct configuration. So we're going to do the exact same thing on CSR4. We're going to go and type in the service instance is going to be 1 Ethernet. Sure, N71, not a problem. We're going to specify the encapsulation is going to be default, so catch all. And we'll configure interface pseudo wire 1. Encapsulation is MPLS. The neighbor is 192.0.2.1 with the VCID of 1. And then the signaling protocol is going to be LDP. And then L2VPN XConnect context, and the name is going to be 1 to 4. Now underneath here, we need to specify the member is going to be gig 4 with a service instance of 1, and then the member of pseudo wire 1. Exit out of that. So now with all of that configured, now you see the LDP peering has come up, which we had before, and CSR1 should see the exact same thing. So now if we jump out of here, no problem, Shoheed. I appreciate you hanging out with me for the time being. Hopefully, I can start doing these on a pretty regular basis, and you guys can take advantage of the material. This will be a live. This will be a permanent video on the video on demand. So all you have to do is once I'm done streaming, you guys can watch it whenever you like. So have a nice night, sir. Thanks for joining. So show L2VPN. Atom and VC. So we have that peering is up. Let's just check 12. Nothing yet. Oh, wait, there it goes. So the peering was up. The peering is up now. So same thing with 15, the peering is up. So that fixed the problem. So on CSR1, if we do a show L2VPN, if we do a and it's service xconnect, and we say all, we can see who we're paired with. So we have the attachment circuit, so how we connect down to the customer. We have the pseudo wire, the remote end of the connection, and stuff like that. So all of that is working correctly and how it should be operating, and all is well there. That's pretty much the basics to it. So if we go back to 12 and do a show IPE edge ERP neighbors, guess who I have appearing with? I have appearing with CSR or iOS v15. If I ping 10.12.15.15, boom, I have a working ping, and that's exactly what you'd expect to see. So pretty cool stuff when you get down to into the weeds and stuff like that. However, this is not as cool as VPLS. And you might say, well, how come, Rob? Well, the reason why it's not as cool is with VPLS, I'm actually able to look on the provider edge router and see the MAC addresses being learned. That's what's cool. Now, you might say, well, that's cool and all, you're able to do on the main interface, but what happens if I need, I have potentially 4,000 customers that I need to peer with? Awesome point. So you could actually take this and start multiplexing it, what they call Ethernet flow points. So an Ethernet flow point, if you were to visualize a circle and then draw a bunch of little circles inside of it. So if you have an Ethernet cable handy, or you know what the insides of an Ethernet cable look like, I don't have one handily available to me without taking my IP phone off the desk. Cut the end off of an, Cut the end off of an Ethernet cable, and you'll notice you'll have the casing that goes around it, and then you'll have 8 individual wires. Consider that like an Ethernet flow point. Each one of those individual wires is an individual virtual circuit between some customer edge and some other customer edge on a remote PE router. Logically, that's what you're trying to create. Let's see. Norman says, pardon me. Oh, cool. So you used to watch me a long time ago, so I appreciate the continued viewership. While you're working to obtain your CCA, I appreciate that, Norman. Out to you. So what I'm going to go ahead and do now is I'm going to jump in and create a couple of, basically a sub-interface, if you will. So the customer side is going to have a sub-interface. On the provider edge side, on the attachment circuit, we're just going to use encapsulation modification. So the cool thing about doing this method right here is with the default, encapsulation default, we're saying I don't care what the actual .1Q tag. In this case here, there is no .1Q tag. You might say, well, how come? The reason why is because the main interface of any router or switch is always going to be VLAN 1 unless you modify it. Hey man, I appreciate that, Norman. I think I'm going to do streams more and more commonly because I think this is more interactive and you guys get more out of it. You guys have been awesome. So I think it'll start to do this more often, and I might actually come up with a regular stream routine. But I do appreciate that, sir. So what I'm going to do is I'm going to create another instance underneath the interface gig 5. So interface gig 5. In this case here, I'm going to type in service instance, I'll say 2, instance 2, I'll say Ethernet. And underneath here, I'll say the encapsulation will be .1Q, and I'll specify VLAN 2, because it's just easy to do. But you can also put a range of VLANs in there as well. So there's that. Then we get to exit out of here. I'll type in interface pseudo wire 2, because it just makes sense to increment up as you're going. We'll type encapsulation as MPLS. The neighbor is going to be 192.0.2.4 with a virtual circuit ID of 2. And then we'll type the signaling protocol is going to be LDP. We'll get out of that. And then we're going to specify that the L2VPN Xconnect context will be 124-2, right? Just make it easy to follow. Then we're going to type in the member is going to be gig 5 service instance 2, and that the member is pseudo wire 2. That'll be that. So now I get to go and type in do show run interface gig 5 and do show run section pseudo wire and L2VPN. So what I'm going to do is I'm going to cheat a little bit. Instead of typing these commands over and over and over again, which just starts to suck after a while, I'm going to configure this like this. Oop, my screen, or I went away. I don't know why that happens, but it does. Oh, I bumped it. That's what the problem is. Oh, well, I can be an idiot sometimes. So we'll do this, and then we're going to go ahead and grab... Wow, my phone is just going off right now. Let me go ahead and mute this. I have a text message. Is it raining out? Oh, that was a while back. Whoopsies. I didn't pay attention too well to my phone. So let me go ahead and mute that because that's just becoming a pain. So the rest of this configuration, I'll go ahead and just grab this right here and this right here and paste them in like this, but I'll nix this line of config and replace that with the exclamation point. So that's the syntax we need to type into the other side, but I need to modify this to be .1. And other than that, we're in good shape. So I'll just copy and paste this right here into CSR4. And actually I need to modify this as well. This needs to be gig 4. So if you have the ability of copying and pasting or just editing as you're going along, this will save you a lot of time. When I was taking the routing and switching CCIE, I spent a lot of time just editing notepad configs. And gig 5. That's my fault. Gig 4. Gig 4. There we go. So let me exit out of that. So that should form appearing momentarily. And then when that is done, we'll do show L2VPN, Atom, and then VC. So they're both up now, which is awesome. So if we do a show Atom, VC, and then the VC ID of 2, and we can see that this is up, and we do a detail, we can tell that it's working, and everything else is looking pretty good. We know what label 34 is the local label, and stuff like that. We do a show MPLS forwarding table. We know that 34 here has been allocated to that particular circuit. We know that. So it's going to be really important for you to be able to understand the individual outputs and how to interpret that. But as long as you understand some of the basics, you should be in really good shape. So let me go ahead and minimize that, and we're going to go back over to IOSP 12. Sir, Hanan, you don't have to be so respectful and formal. You can call me Rob. Cisco FTD. Yeah, I could do some stuff on FTD. I haven't done a ton with FTD. I've done some basic stuff with it, like security intelligence and some DNS filtering, things like that. But sure, I can put some together for FTD. I don't know when I'll be able to do that, but I can certainly put something together for you. Is there anything specific you're looking for, or just FTD in general and just a little high-level overview, or do you want it like down in the weeds type of stuff where it's a deep dive? But beyond that, on IOSP 12, if we go to gig 1, interface gig 0/1.2, encapsulation .1q2, IP address is going to be, we'll say 10. We'll type in 10.0.2.12/24. And then over on CSR or IOSP 15, interface gig 0/1.2, encapsulation .1q2, IP address is going to be 10.0.2.15/24. And then do ping 10.0.2.12. If I've done my job correctly, we should get a ping here in just a moment. Boom! That's exactly what I'm looking for. So the ping works. Now if we type in router EIGRP1 network of 10.0.2.0, 0.0.0.0, and sorry about that. Sometimes they sneak up on me. And we type in router EIGRP1 network of 10.0.2.0, 0.0.0.255. Boom, we have an EIGRP adjacency. So that is going to be the layer 2 VPN with the both the main interface and a sub interface. Well, in the case of the CSR, if we look at the show run interface gig 5, it's not a sub interface, right? We're not creating sub interfaces on gig 5. We're leveraging what they refer to as Ethernet flow point to allow us to take full advantage of the entire interface. So this could be done to a gigabit interface, it could be done to a 10 gigabit interface, it could be done to a 40 or 50 or 100 gigabit interface. And what you would simply need to do is your only limiting factor is the amount of VLAN IDs and the amount of VLAN IDs is really your only limiting factor. Because to my knowledge, there's no way to VRF break this down. So it really needs to be, you need to think about this as you're going along. But you're not limited to a single VLAN ID either. You could do multiple VLAN IDs. You could do a range of tags that the customer could send you. So, which we kind of looked at that very briefly. For whatever reason, I've never had success getting that to work in the lab. I don't know why. Maybe it's just a virtualization limitation. I really don't know. But what I do know is in production, I've had customers that we have what they call the S tag and the C tag. The S tag is what the service provider uses across the backbone, which is the old .1Q tunneling technique. We're not really doing that here, but you can double tag, or what they call Q and Q, 802.1Q inside of 802.1Q. And the idea is the outer tag is the service provider tag, and then the inner tag is the customer tag. But you're not limited to just a single tag for the customer. You could have a range of tags. It could be, 10 and then 25 through 50 or something along those lines. So the option is there, and then there's some advanced configurations you can do with like longest match on the tagging. So you can specify, you're going to be pretty generic and say, okay, if I receive this tag in from this customer and anything else that comes in behind it, I really don't care. Or you can be very specific and say, I'm only going to receive tags 10, 20, 30, and 40 from the customer. So it's up to you to make that policy. Unfortunately, when I've tested that out, I have not had good success with it. So I won't bother wasting time trying to show you how to configure something that won't work. So beyond that, that's the layer 2 VPN in a point-to-point. What I'm going to do now is I'm going to jump over to CSR 7, which is down here at the bottom. Go ahead and scrunch this down just a little bit. And we're going to take a lot of the same configurations, but what I'm going to do is I'm going to do VPLS. VPLS is pretty simple. It's a manual configuration, and this is not the same thing as VPLS with BGP Auto Discovery. This is going to be just a manual configuration where you basically are going to be configuring pseudo wires between the different nodes. So think of these as just tunnels between the PE routers that are going to be used to tunnel layer 2 traffic between the customer edges. So IOSv2, IOSv12, and IOSv15 will all have communication with that. And the benefit to that is I have worked with some customers in the past that have set up layer 2 connectivity to Amazon and Azure, and I think what was the other one? I forget what the name of it was. It wasn't anything. It wasn't a Rackspace maybe. I don't remember. It's been a few years. But we set up layer 2 connectivity, so we were able to send the data to them, to the content provider for the cloud provider, and stuff like that. And we were able to propagate that information. Godday asks, is it possible to do the service instance on sub-interface? Good question. Let's find out. So let's say interface gig 5.10, encapsulation .1Q 10, and service. Nope, sure isn't. Command's not there. So not on a sub-interface. Well, let me get rid of the encapsulation and try. Let's do service. You can do service insertion, service policy, and service routing, but not a service instance. Service instance is not supported. So not on a sub-interface. And I knew the answer to that, but I wanted you guys to see it firsthand. And the reason why they don't do that is because they don't want, Cisco doesn't want you trying to limit the configuration based off of the sub interface configuration. So you could specify encapsulation.1q and say 10, and then you could say second and say, 10 or 20 through 30. That's valid syntactically. That would work. If I hit the enter key, that would work, right? So you're saying the provider tag is 10, right? Because this is the outer tag, and the inner tag is you're going to accept VLANs 20 through 30 from the customer. Okay, that's what that's doing. But on they don't want you doing that because now you're limited down to a sub interface, so you can't have more than one customer on that particular interface. So you might say, well, that could work, because then you could have as many as 10,000 or so sub interfaces. Well, theoretically, yes, you could do that, but that defeats the purpose of the service interface, or service instance, and the Ethernet flow point. They're trying to make it less sub interface and make you leverage the service instance. But here's the one main drawback to some of the stuff that I've seen with this. Once you get out of the point-to-point layer 2 VPN design and you get into the multi-point layer 2 design, you're not going to be trying to slam 2,000-3,000 customers on a single interface. You're just not going to do that. And the reason why is if you have a multi-point to multi-point design, let's say IOSV 12, IOSV 2, and IOSV 15 all need to be able to communicate with one another, dynamic routing, propagate routes, whatever's needed business-wise. And you're doing VPLS, the limit that isn't going to be the number of customers you can attach or the number of service instances that you can create. Your limiting factor is going to be the amount of MAC addresses that you learn, and then you have to propagate all that. So you'll see what I mean by that here in a minute when I go to actually do it. Because if you have hundreds of MAC addresses that are being propagated, because not every customer is going to terminate the circuit, so the CE side won't always be a router, it might be a switch, then that switch might connect into a large layer 2 domain. Well, if the customer's domain has 350 MACs, then those 350 MACs are going to get propagated up to the PE router, and then that PE router is going to have to propagate those 350 MACs to both however many other provider edges that are out there. So then you run into a MAC scaling problem. So typically speaking, you're not going to see a scaling limitation in the terms of service instances. You're going to see it in MAC addresses and stuff like that. But so I'm just going to go ahead and get rid of no interface gig 5.10. So, but yeah, I'm actually glad you asked that, because it's one of those things where I see people accidentally doing things that they shouldn't be doing. But it's a learning experience all the way, and no problem, God day. I'm glad you asked. So with that being said, I'm going to go ahead and I'll set up CSR7. CSR7 isn't that much of a stretch to do. And I'm going to use, we're going to use a single VLAN. We'll use VLAN, I don't know, like 100 or something. So I'll type in interface gig 5. Service instance will be 100 and Ethernet. The encapsulation will be .1q and Ethernet. .1q or .1q 100. So what I'll do now is I actually have to go and create the pseudo wires. There's gonna be one to CSR4 and one to CSR7. So interface pseudo wire, and I'll call this one 14. And this encapsulation will be MPLS, and the neighbor will be 192.0.2.4 with a ID of 14. And remember, these numbers have to be the same both ways. So 14 from 1 to 4, 14 from 4 to 1. And then I'm going to get out of here and then type in interface pseudo wire 17. The encapsulation will be MPLS. The neighbor will be 192.0.2.7 with a 17 as a VCID. So now we have that. So now I get to go to L2VPN, and then instead of typing the XConnect config, I need to type in the VFI. Think of the VFI like a port channel in a way. not one for one. It's loosely analogous to the port channel, but the VFI is going to basically allow multiple pseudo wires to be joined to a single connection. So a single attachment circuit or several attachment circuits depending on the situation. So the VFI is kind of like a port channel in a way. And we're going to specify the context name here, and we're going to say VPLS. And then we need to specify the VPN ID will be, in this case here, will be 100. And then we need to specify the members. So we'll type in the member will be pseudowire 14 and 17. And you'll notice that that's all I can do here. I don't have the ability of saying member and then a remote peer. Okay. What I do now is I type in the bridge-domain command, and we type in here the bridge domain is going to be, the bridge ID is 100, and underneath here I specify the member, and I have to call gig 5 and the service instance of 100, and I also have to call the member, and down at the very bottom here you'll have the VFI, the virtual forwarding instance. So we'll type in VFI, and underneath here the name of it is VPLS, and then hit the enter key. So if I exit out, so now you notice it goes from down to up, and if I, that's the config. So you first have to, so the first step is underneath the interface, gig 5, is define the service instance. The next step is do show run pseudowire. Define the pseudowires, which are going to point to your remote PE routers. Configure those. The next step is define your layer 2 VPN VFI. And I've done that right here. VPLS, VPN ID of 100. I've tied both pseudowire 17 and pseudowire 14 to this. Now that just brings those connections in. Now then the last step is do show run section bridge domain. And here we have the bridge domain, and we're all squared away there. So now what I need to do is I need to replicate all 4 of those steps onto CSR4 and CSR7. So this is where copy and paste will come into play and become very handy. So that's why I actually typed it all out, so you guys I can literally just tweak it as I'm going. So I'm just going to grab all this syntax and paste it into Notepad. So Anon asks, in real-world SP Core, would the provider use public IPs for these configurations? Are you referring to the IP addresses for the remote peers of the provider edges? And if that is the question, if that's what you're asking, no. Normally you're going to use a private IP address, but it's typically you're going to use things like ISIS, and you're going to do you're going to advertise passive only, which is going to be the loopback. So you're only going to have loopback addresses in your provider core and labels associated to that. You're not going to have a provider core that looks like this. You're not going to have a bunch of /24 sitting in there. You're only going to have /32s, and specifically only the ones to the loopbacks of the provider edges. So unless you're doing traffic engineering and doing a provider edge to provider core TE tunnel, and yeah, just the core devices. So the core devices, which would include PE routers and PE routers. So here I'm just demonstrating how to configure it, not the efficient way of doing it, just a way of doing it. So let's go ahead, and I'm going to go and nix all of this configuration, because this is going to be one of those things where this is the time-consuming part, to retype it over and over and over again. Yeah, that's just going to suck. So let me do this right here. No problem, Anon. Glad I could answer your question. Oop. And there. This is the syntax in its entirety that needs to be applied. So we have the service instance that we configure underneath the interface. We specify the encapsulation. Then we need to specify the the pseudowire interfaces that need to be defined. And then you have the VPLS configuration that calls the pseudo wires. And then fourth, you have the bridge domain that calls the pseudo wire, or the VFI, and the attachment circuit interface. So all I have to do is on gig CSR4, I'll type in gig 4 here. And on this guy here, I'll type in .1, and this guy will be, I'll say 47 here. And this will be 41, and this will be 47. And then underneath here, I'll type in 41 and 47 so that I know where I'm sending this traffic to. And the last portion right here will be gig 5. This is actually gig 4. And so now with that being configured the way that it is, I should be able to just copy and paste this into CSR4 and get him operational. And go ahead and copy and paste that in, exit out. So that came up. Now, one thing that we haven't done is on the customer side is we haven't configured anything on the CE side to start propagating traffic. So I'll do that in here in just a minute once it gets CSR7 done. So on CSR7, let me see what his interface is. And that's going to be gig 4 as well. Gig 4 as well. And then we're going to say this will be 71. And this will be to 17. And this one will be to 74, which will be 40.4 to 47. Then we're going to call 71 and then 74, and make sure I've got all that ready. That should be good to go. So we'll just copy and paste that into CSR7. And we actually have to no shut gig 4. So I'll go ahead and just type this command in. I'll type in interface gig 4, no shut the interface. So that should take care of that in just a moment. So that's basically where we're at with that. So now I have my my connections to 1 and 4 are up. Now I'm going to go, now that I've gotten that configured, let's go over to IOSB 12. And on interface gig 0/1, we'll type .100, and we'll type in so I already have a 10.1.100.12, which is fine. So I don't need to do anything there. And the same thing with IOSP 15. I already have I don't have one here yet. So what I will do is on interface gig 0/1.100, encapsulation.1Q100, and on 12 I use 10.1.100.12. So 10.1.100.15/24 IP address. And then what I'll do is on iOS v2 down here is interface gig 0/1 no shut it, and then .100 encapsulation.1Q100. IP address is 10.1.100.2/24, and that will come online. And then what I'm going to do is router EIGRP1 network of 10.1.100.0 0.0.0.255. So what I'll do is I'll take do show run section EIGRP. I'll take that configuration, I'll apply it to IOSB 12 and 15 respectfully. And on 12 and on 15. And I have adjacencies up to 12 and to 2. So you know what that means? I think you guys can figure out what that means. I think you guys will realize that that means that my VPLS configuration is working. So if we do a show bridge -domain 100, give that a moment, and I am learning MAC addresses, which is exactly what I expect to see. So that means that the VPLS configuration that I wanted to get operational is working the way that I intended it to. So we have, so just to interpret this output, you can basically ignore this authorized edge device, which is basically more of an OTB specific configuration, but I'm not going to dive into that at all. Then we have the MAC addresses that we've learned. We've learned 3 MAC addresses. We've learned 1 in out the Ethernet flow point from gig 5. So this is iOS v12's connection to us. This is our attachment circuit. And then we have these 2 right here. We have these BPLS pseudo wires. So these connections right here are going to be the connections to iOS, CSR4 and CSR7 respectively. And because we have it set up the way that we do, then we can go and we've got everything operational. So if I go back to iOS v2, I have 2 EIGRP adjacencies. We do a show IP EIGRP neighbors. I have 1 to 12 and 1 to 15. So you can totally dynamically route across this traffic. And that's the the point here. What's really cool about this that I really like is when we look at the IP addressing here, let's assume for just a moment that iOS v2 is a cloud-based router. Some cloud providers network that allows connectivity into an MPLS domain for both layer 3 and layer 2 VPN. All the service provider would have to do is do some configuration on their attachment circuit in order for that connectivity to happen. The subinterface on the provider or the customer side, so iOS v2, would just need to be modified. You could even throw it into a VRF if you wanted to. You can VRF it off and not allow communication to happen between the VRFs. So you can multiplex it and do a multi-VRF CE deployment. So lots of options for you if you wanted to take it that route, which gives you a lot of security scaling and stuff like that. So pretty cool stuff when you get down to the weeds. But that in itself, ladies and gentlemen, is a layer 2 VPN. And I did the main interface, I did a sub interface, or I should say 802.1q, and then I did VPLS with a VLAN ID. So you could take it deeper, obviously. There is HVPLS, there's VPLS with BGP auto discovery with BGP and LDP signaling. I'll be covering those videos as well, and stuff like that. But beyond that, that is pretty much everything that I wanted to cover when it came to layer 2 VPN. It's pretty straightforward stuff. The next step, and which will wrap up the our stream here because we're a little over 2 hours into it, is MPLS traffic engineering. And so we're just going to do a little bit of it to test this out. Okay, and this is one thing that I actually have never tested. So I don't know if this is going to work. You guys are going to be, this is a test bed information at the moment. But I have downloaded some documentation that I will be using to help me out with this, even though I think I know how to configure it, which is going to be inter-area OSPF multi-MPLS traffic engineering. So give me a moment. Anon asks, do you find it easier to lab this in Eve or on ESXi devices like you did previously? It's kind of one half does the other. I don't see any value, anything easier per se. They're both relatively straightforward on both devices because at the end of the day, whether it's in Eve or it's in ESXi, it's the same version of code. So the syntax is the same. I find it easier in Eve to get everything wired together, because then I'm not having to configure sub-interfaces and then worry about creating additional V-switches to allow the communication between CSR1 and iOS v12 and having to do all of that and troubleshoot that as a potential problem. Here, it's just physically dragging a cable or a virtual cable, if you will, from one device to another. So in my opinion, it's actually easier to get the lab operational than it is than ESXi. But because ESXi was what I was familiar with and comfortable with, it just made sense from that perspective. But there's a level of that. Let's see, 2100. I think this is what I'm looking for. Yes. So I went to Cisco Live in San Diego, and one of the things that a session I went to was deploying traffic engineering in MPLS and segment routing backbones. And the guy that delivered the discussion, his name is Greg, really nice guy, really knowledgeable on MPLS, does a lot in the federal space. And so he walked through all this. Now, if you don't know how MPLS traffic engineering works, there's a lot to it, and I don't want to spend a ton of time diving into the details, but what I will do is I will give you guys whatever time it takes for me to get this up and running. We'll go through those details and stuff like that. Hamza says terrassology. I'm not sure what that means, but let me go through here at the bottom. There's some reference configs. Let me find it real quick. And the only reason I'm showing you guys this stuff is because it's Cisco public. Let's see. Here's his reference slides. Let's see. Where it should be right down here. Yeah, inter-area tunnels. So basically the idea with inter-area tunnels is normally when you deploy MPLS traffic engineering in a level 2 domain with ISIS or area 0 only with OSPF, it's really not that difficult. But because you need to have full visibility of the link state databases in order for this to work with the TLVs, you need to have a way for the traffic engineering tunnels to know where to send the traffic and how to do that path calculation process. So you need to configure a explicit path that calls the area border routers that you're going to be using to send the traffic over, but you need to call the area border routers in play. So you need to, basically what you're doing is you're calling the type 3 LSAs, and you're saying, okay, area border router for whatever area, I'm going to use your router ID in order for me to calculate my path to the end destination. So this is IOS6C with a static route. I'm going to use auto tunnel destination like it shows here. So I'm literally going to use this syntax, except for my destination addresses are obviously going to be different. But I'm going to configure one from CSR1 to CSR4 and see exactly how that plays out. But this will just be for, what do you call it? This will be for, I'm having a moment at the moment. I can't remember what I was going to say. The path, let me see which path it takes here real quick. Show IP route. Let me trace route to 10.15.1.100, sourcing from loopback 0 numerically. I take a path, I hit 5, I go to 1.5, which should be this path towards CSR5. Then I go to XRV9, and then I go to CSR4, and then I go out towards the customer. So I know what path I'm taking. So now I just need to configure a TE tunnel on CSR1 to call CSR5, and I'm going to go the explicit path specifically states to call the ABRs as loose hops, which is not hard to do. It's easy to do. But what my current path is, based off of the IP address on IOSP12, is going 5 to XRV9 to CSR4. So I'm going this path right here and back up. So I could say 5, I'm going to try 7 to 8 to try to change the path based off of that, which is the whole point of traffic engineering. So on CSR1, I'm going to go to global config and type in interface tunnel 1, and the IP unnumbered loopback 0, which is very common to do, and that the tunnel destination will be 192.0.2.4, and that the tunnel mode is MPLS traffic engineering. And there's other options here with multi-LSP, but we're not going to worry about that. And then we need to specify that the, I'm going to exit out of here real quick because I haven't specified the explicit path. So IP explicit path, and the name will be explicit path inter area, and it automatically gets enabled. So then what we're going to specify is the next address is going to be, and we're going to specify as loose, and we're going to specify 192.0.2.7, which, or I think XRB7 is 7. Show IP interface brief. 17. 17, and then 9, 8 should be the same. Eight. Okay, perfect. So it'll be 17 and then 8. So now when I exit out of that, I'll type in the interface tunnel 1, the tunnel MPLS traffic engineering path option. Path option 10 will be explicit name, and it'll be explicit path enter area. Now, that'll simply get the tunnel to come up if I've done everything correctly. So the tunnel came up, which means it was able to signal end to end. So do show IP interface brief. That's a really good sign, because if there's something wrong with my syntax, then, or my logic in the flow, then this wouldn't have worked. Now, we're not actually sending traffic over that particular path because there's no tunnel 1 anywhere in the routing table. If we want to send traffic over the tunnel, we need to type in the MPLS or tunnel MPLS traffic engineering auto route, and we're going to specify destination. And then with that being typed in now, we do show IP route, you'll see the tunnel 1 for this traffic right here. It's now directly going out tunnel 1. Before, it was going out 2 different paths, either gig 2 or via port channel 15 between CSR1 and CSR5. So now my trace route should be different. If I hit the up arrow, my trace route should take me, it takes me the 1 to XRV7, and then XRV or router 5, then router 8, then router XRV10, then to 9, then to 4. Holy cow, it takes me around the block. I wasn't expecting it to do that. So it actually takes me CSR1 to XRV7, XRV7 to CSR5, CSR5 to XRV8, XRV8 down to XRV10, XRV10 to XRV9, and then XRV9 to CSR4. Wait, 415? Yeah, to CSR4, and then from CSR4 down to iOS v15. So it takes us a long way around. So it's a long way. I still have to, I'm not exactly sure why it does that, because I know in regular iOS with non-inter-area TE tunnels, it doesn't do that. That might be just the fact of me taking it the path that I took and it having to bang around to figure its way out. I'm curious to see if it's going to continue to take that path. Yeah, it continues to take that path. So we know it's one label switch path because we see 50, 50, 50, 50, 50, 50, and then 50. So we know it's working. We know it's going around and around and around. But that's basically how that comes into play. And that's inter-area traffic engineering. So we're about the 2.5 hour mark. We covered a lot of stuff, and I'm actually really happy that it worked out the way that it did. I was able to talk to a lot of you guys. The chat was awesome. Really happy with the way that it worked out and stuff like that. So I'm going to, I think that's pretty much as far as I want to take it for right now. If anybody has any questions or anything like that, please let me know. And if not, it was awesome hanging out with you guys. It's about dinner time for me here. I'm not really hungry, but that's pretty much the end of the stream. So I think I'm going to start doing this on a regular basis where I do demos of different technologies and stuff like that, and maybe you guys take advantage of it, and maybe you don't. It's up to you. But I'm going to wait a minute to let me go ahead and move the mouse around and see if you guys can how long it actually takes for that to move. But beyond that, guys, I'd like to thank you for stopping by. If you have any questions, or would like to see something specific, let me know in the comments. I'll take note of what you ask and go from there. But I do know that there was some FTD training that somebody wanted and stuff like that. So you guys have been awesome. It's about a 30-second delay, so I'll wait until you guys are. I'll wait a minute, and if you guys have any questions, let me know. So Anon asks, will you work on some new stuff in February for the new SP test? Yes. I will be doing some stuff on that. I probably will be doing that before February, just because of the fact that the new technologies are going to be dropping. Just so you guys are aware, the SP blueprint isn't really changing. They're just adding more segment routing and more automation to it. So the actual blueprint itself hasn't changed a whole lot. They've gotten rid of things like Lisp. They're no longer asking you to know how to do all that. I don't know why it was on there to begin with. But other than that, those are the topics that haven't really changed. They just added more emphasis on segment routing, which I'll be covering in an upcoming session. So I think I'll start going live on. I'll figure out a schedule. But you guys are awesome. Thanks so much for hanging out with me. Thank you, Norman. Thank you, Muhammad. I really appreciate you guys hopping in here with me. And tell your friends about what's going on. And hopefully we can get something routinely going. I will be putting stuff on the Patreon here in the near future. So keep an eyeball out for that. There will be a link in the description below once we start doing that. Until next time, guys, thank you so much for stopping by. And keep on doing what you've been doing. You guys are awesome. And we'll see you on the next stream. Take it easy, guys.